We've got one last set of identities to go over, and these are the double angle identities and the half angle identities. And you'll see that these are on your formula sheet. Okay, so the double angle identities are if you're trying to find sine of 2x, cosine of x, or tangent of 2x. So they're all there. And the half angle identities are if you're finding sine of x over 2, cosine of x over 2, or tangent of x over 2. And you'll notice these have a plus or a minus out front. You'll choose the plus or a minus based on what quadrant your angle would be in. Okay, so first we're going to use the double angle identities. This says if, and that's missing something. So this should say, if sine of theta equals 24 over 25, and theta lies in quadrant 4, find the exact values of sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. So the first thing we want to do is draw our angle. So if we're in quadrant 4, that can't be sine. This must have been if cosine of this, because that would be the only one that would be positive. Okay, so here's our theta. So we'd have 24 over 25. And we need to use the Pythagorean theorem to find this side. So we'd say 24 squared plus b squared equals 25 squared. So b squared is equal to 25 squared minus 24 squared. So b is going to be the square root of that. So let me pause this and grab the calculator. Okay, so here's our calculator, and if we do that, square root of 25 squared minus 24 squared is 7. So this b is 7. Okay, so now we'll know, we'll be able to find all of our values, the trig values of theta. Okay, so let me go ahead and erase kind of the scratch work. Okay, so we want to find sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. So sine of 2 theta is equal to 2 sine of theta times cosine of theta. So 2, and since this is going down in the negative direction, this should be a negative 7. Sine of theta would be opposite over hypotenuse. So this would be negative 7 over 25, and cosine is 24 over 25. So we can take on our calculator 2 times negative 7 over 25 times 24 over 25. Put it in a fraction, and we get negative 336 over 625. So that's what sine of 2 theta is equal to. Okay, now we want cosine of 2 theta. And cosine of 2 theta, you'll notice we have 3 different ways that we can write this. And it doesn't matter which one we do, but let's go ahead and just take the first one. So we want cosine squared of x minus sine squared of x. So that means we're going to take cosine of theta. Yeah, those should be thetas instead of x's. So cosine of theta we know is 24 over 25. So we're going to square that, minus negative 7 over 25 squared. So cosine of 2 theta will equal, we can do this in our calculator, and so cosine of 2 theta is equal to 527 over 625. And finally, we want to find tangent of 2 theta. So that's 2 tangent of theta over 1 minus tangent squared of theta. So this is going to be 2 tangent of theta is opposite over adjacent, so negative 7 over 24 over 1 minus negative 7 over 24 squared. And so tangent of 2 theta is equal to negative 336 over 527. Okay, so by setting up the triangle and then using the identities, we were, just by knowing what cosine of the angle was, we were able to find the exact values of sine of 2 theta, cosine of 2 theta, and tangent of 2 theta.